In this video, we are going to discuss example 31 to integrate a functions in the form that is shown on the screen. The integrand is in the form of 1 over 1 plus x squared, and the limit is starting from minus infinity to positive infinity. In comparison to the previous example, here we have two limits to go to infinity instead of just one. However, the idea to perform the improper integral is the same as the previous example. The procedure for carrying out this improper integration is divided into two steps. The first step is to replace the infinite limit by a finite one, say b. Once the expression for these integrations is obtained, then we will take the limit of b to infinity. The resultant value or the expressions of the form of the integrations in the limit b goes to infinity would then be the answer to the integrations we want to find. So let's look at the first steps. To obtain the integrand with lower and upper limit minus b and b, we first perform an integration on the functions of 1 over 1 plus x squared, and we call the resultant integrations a function named capital F. The indefinite integrations of 1 over 1 plus x squared could be obtained by referring to the integral table in module 5. If you go to module 5, scroll through the integration table. In the part of the integration table that involve function a squared plus x squared, you find these results. That is, the integrations of 1 over a squared plus x squared is simply in the form of an arctangent. In our case here, we have 1 instead of a squared. So the answer for this is quite straightforward. According to item 32, the result of the integration of 1 over 1 plus x squared is simply arctangent x, with a taking the values of 1. So that is the answer to the indefinite integral, and we would have an arbitrary constant here. Therefore, the improper integrations with the lower limit minus b to b can then be simply expressed as the capital F function evaluated at b minus the function capital F evaluated at f minus b. Here I will write down small function fx to represent the integrand. Fx is an symmetric function in the sense that if you revert the sign of the x, you get back the same value. Okay, so we said the integrand small function f is an symmetric function. Sometimes we also call this an even function. For an even function, the integration from minus b to b is just the same as the integrations from 0 to b. That is because the values of the function evaluated at minus b and b are the same. So we have these very nice results that will help us to simplify the integration we are dealing with at the moment. That is, the integrations of this is simply equals to 2 times the capital function f evaluated at b. With these results, then the expression for the integral of the function 1 over x squared integrated from minus b to b could then be simply written down as 2 arctangent x, and there will be no constants because the difference in these two terms will cancel off the constant. By right, I should replace x here by the values of b instead of x. So that finished up the first part of obtaining the expression for these integrations in terms of b. The next step is to take the limit of b to infinity. So in the next step, I'm going to set b to infinity for the integrations we are currently considering. That is the same as taking the limit of b to infinity for 2 arctangent of b. What is the behaviors of the arctangent of b when b goes to infinity? The answer to these questions can be obtained by either referring to the graph of the arctangent or by referring to the definition of the arctangent. Here we would try to provide the behaviors of the arctangent in the limit b goes to infinity by referring to the definition instead of using the graph of arctangent. Let y be arctangent x. That means the tangent of y is x. So you could try to represent this relationship of tangent y equals to x on a right triangle. Here it would be y and x would be the opposite and the adjacent should be 1. Now you can see what happened when you let x tends to infinity. If x tends to infinity, the angle of y would tend to 90 degrees. You can try to imagine this by making x to increase. So when x is increased to a very huge size, then the right triangle will grow in height and the angle of y would then tend towards 90 degrees when x tends to infinity. So we can work out this relationship that when x tends to infinity, y tends to 90 degrees to answer the questions of what happened to y when x tends to infinity. Here the y is representing the arctangent of b and x here is representing b. So with this argument, we could quite comfortably arrive at the answer that when b tends to infinity, arctangent of b would just goes to 90 degrees. Again, I made some typo error here. This theta should be 90 degrees, pi over 2 instead of theta. So the answer for the limit of the function 2 arctangent b when b goes to infinity is simply 2 times 90 degrees, and that would be just pi. So we come to the conclusion that the integrations of 1 over x squared integrating from minus infinity to positive infinity is just simply equals to pi. In conclusion to this video, we have discussed example 31 where we are integrating improper integrand of 1 over x squared with the lower limit minus infinity and upper limit positive infinity. The integrations of this improper integral is to be obtained by first calculating the expressions of this proper definite integral where the lower limit and upper limit are finite in terms of b. We show that the expressions for these proper and finite integrals in terms of b is just 2 arctangent b by referring to the integral table. Next steps is to then take the limit of b to infinity. Taking the b to infinity will cast the integral in terms of b into the form of pi by referring to an triangle written down to represent the arctangent relationship. These very simple visualizations of letting x going to infinity, we can conclude that the angle made in the right triangle, which represents the values of arctangent, is tending to 90 degrees. Therefore, we arrive at the results that the limit of this integral when b goes to infinity is just pi. Therefore, the improper integrations we are considering is convergent into the values of pi. We can conclude that the angle made